All right, good morning, guys. This is Monday, April the 6th, and this is arithmetic sequences. So, yes, this is stuff that we have already done before. If you look back in your binder, you'll probably be able to find these notes. However, the district and our principal has asked us as a Math 1 group, all the teachers that are teaching Math 1, to get on the same material and to go back and review other material. So you will find new material, but we're all sticking to the same page. And if you're completely honest, you can't tell me that you remember every single bit of this. So a review will be great. If at any point you understand all of this and you want to just go on to the homework, that is perfectly fine. So you can see in the Google Slides that I've put the key to this as well. And I put that on there just because I understand that, yes, you can look at the key and just copy it down, but if you don't know what you're talking about, like I always talk about in class, you can copy down hieroglyphics. It doesn't mean you know what they mean. So the same thing here, you can just copy that down, but I want you guys to make sure you understand the material. So an arithmetic sequence, as you can see down there, is a sequence where the difference between any two consecutive terms is constant. In other words, it keeps increasing or decreasing by the same amount. And that same amount is your common difference right there. So determining whether the sequences are arithmetic. Here for number 1, yes, they are increasing by 4, so our common difference is 4. For number 4, I'm going to skip around, we are decreasing by 3 every single time. So yes, we do, but our common difference is a negative 3 because we are decreasing by 3, okay? Now look at number 5. 5 to 10 is 5, 10 to 20 is 10. Immediately right there, no. This is not an arithmetic sequence because an arithmetic sequence only increases by adding or subtracting something, okay? But remember, if you are going down, then your common difference is a negative number, okay? So for 7, 8, 9, given that this is an arithmetic sequence, find the next 3 terms. So this is increasing by 4 each time. So we're going to keep increasing by 4 each time. Not too bad, right? For number 9, we are actually increasing still by 6, right? We're adding 6 to each of them, so that'll be 16, 22, and 28. All right, so our formula, our arithmetic sequence formula, if you will recall that it is a sub n. In other words, a or n is that number in the sequence. Okay, so in other words, if I was numbering these, that would be the first number, second, third, fourth, right? I could go all the way up to like 100, and I could find a sub 100, like the 100th number in this sequence. So that's what the n represents. It's just the number in the sequence. And then you have the common difference multiplied by n minus 1 plus a sub 1. In other words, the first term in the sequence. So d is the common difference. Ooh. There's 2 m's in there. Common difference. It's been a while, I guess. And a sub 1 is the first term of a sequence. All right, so from there, we're going to take the first term and the common difference, and that's what we are applying in this formula. That's the only 2 things we need. So we're going to set up and keep the n inside first. So a sub n, our common difference here is 6. We are increasing by 6 each time. N minus 1, and then we plug in our first term, which would be 7. Okay, so that's setting up the rule. That's writing the rule for the nth term. In other words, you can ask me the 100th number in this sequence, and instead of adding 6 every single time, we can go straight there by plugging in 100 for n. Now, we're not going to do that. What they have asked us to plug in is 19. Okay, so what we're going to do is we're going to do a sub 19, and we're just going to plug in 19 there. So that will be 6 times 18, and then we would add 7 to that, and that will give us 115. That's what the key says. I don't have my calculator with me. 6 times 18, 60. Yes, 108 and 7, 115. Good. All right, so that is writing a rule and then finding that nth term. So we're going to keep doing this. I'm going to skip around because you do have these in the answer key below. Let's find one where our common difference is negative. Let's do this one, number 14. So we are decreasing by 5 every time, right? So our common difference is negative 5. And then our first term is a negative 16. So to set this up, we need a sub n. We write out our common difference, n minus 1, and then we add our first term. Yes, that could be minus 16, but plus negative 16 is not incorrect. So then they asked us before, we're still in the same section, we're still going to do 19. Now, we don't do 19 every single time. I don't want you guys to think, oh, 19 is a magic number. No, I mean, I could ask you for any of them. I could ask you for 18. I could ask you for 26. I could ask you for 1,000,000. Either way, instead of subtracting 5 every single time and just, I mean, if you subtracted 5 and I asked you for the 100th number in the sequence, that would take you like at least 3 minutes to do it on the calculator. Minus 5, enter, minus 5, enter, minus 5, enter. And then you're like, you get to 47, you're like, was that 47 or 48? I don't know, right? So this sequence and this formula gets you straight there. So what we would do is we would do negative 5 times 18 minus 16. And that would give us negative 106. Cool. All right. So then we're going to get to some real life applications. So you visit the Grand Canyon and drop a penny off the edge, right? So this penny is falling off the edge. And there's you. Okay. So the distance the penny will fall is 16 feet for the first second. In other words, that's 16 feet. And then 48 feet for the second second. And then 80 feet for the third second, right? So write a formula to represent the sequence. Pretty much what they're giving us is 16, 48, 80, and we're saying it keeps going. The Grand Canyon is pretty massive. I've actually been there before, and you are literally a mile above the bottom, the Colorado River. So it's like 5,280 feet. So you got a while to do this. So write a formula to represent this sequence. We're going to do our common difference, and we're going to do our first term. So our first term is 16. And our common difference is we are adding what? 32? Yeah, adding 32 each time. So our formula, we'll just set up the formula. That's all we're being asked. A sub n equals our common difference, n minus 1, plus our first term, 16. So how far will the penny have traveled after 6 seconds? All right, so the first second it traveled 16, second 48, 80. We're just going to plug in 6. For n. 32, 6 minus 1, plus 16. Also, I didn't say this before, but I did in the watch this first video. If you don't have a calculator on your phone, regardless of whether you have an Android or iPhone, there is a free app online that you can go down in our Google Classroom to the helpful info page. And I've got the names of those on the App Store or the Google Play Store. And it's a free calculator just like what we have in class. It's awesome. I highly suggest it. So, how far will the penny have traveled after 6 seconds? That will be 176, and we are using feet. So that'll be 176 feet. There's our answer. Okay? All right, so the total bank loan for Sarah's new car is $15,265. I'm about to pay off my car. I know we talked about that in class, and I gave you guys that lesson. I am super pumped about it. Anyways, the bank automatically withdraws $295.80 each month to pay the car. So, if her total bank loan is that number, and obviously that's how much Sarah owes, right? So she owes the bank $15,265. She pays $295.80 per month. So that $15,265 is going to be decreasing. So that means our common difference is going to be a negative. And that's going to be negative 295.8. Right? Because we want that number to decrease. That's how much she owes. That's a lot of money, right? So she wants that to decrease. And then our first term is $15,265. That's where she started out as. So to write this formula, we are going to use a sub n, our common difference, which again is a negative. That's going to be the biggest thing to trip you guys up. This is a really easy topic, but so many people will forget that there's a negative when it's decreasing. Okay, so she's paying that each month. Now, it says what will be the balance of the loan after 2 years. So obviously there are 12 months in a year, so there's 24 months in 2 years. So we're actually plugging in 24 here. Be very careful with that too. Negative 295.8, 24 minus 1, plus 15,265. When you type that all in, her balance of the loan after 2 years is 84.61 and 60. Now again, we're dealing with money, so that's not 0.6, it's 0.60, and it's $8,461.60. Now, that's after 2 years, right? You guys remember the lesson I was telling you to stay out of debt and to watch for interest and stuff like that. You need to pay that off as quickly as possible. I had a loan, I'm just a teacher on a teacher salary, and I had about that size loan, and I'm going to pay it off in under 2 years because I'm throwing everything at it. Try not for the bank to steal that free money, which is interest, like we talked about, right? So there is your lesson on arithmetic. I do want you to complete the homework. You can either type it into Google Classroom, or you can print it off or do it on a loose leaf sheet of paper and turn it in to me. We're not doing odds and evens. I do want you to do all of those. If you have any questions, feel free to shoot me